This is traditional pour buoy inner string cementing. A drill pipe inner string suspended beneath a traditional cart. During normal cementing operations, the expectation would be that the cement slurry comes out of the inner string into the large bore conductor casing, being subject to various levels of contamination prior to exiting the casing chute, then coming up the casing eyeglass. So the difference between the traditional pour buoy inner string cementing technique and SeaCure is the inclusion of the simple SeaCure bottom hole assembly, which goes at the bottom of the inner string, consisting of the SeaCure slip joint tool, SeaCure weight set sub, and the SeaCure latching adapter, all in approximately the length of one joint of range 2 drill. This connects the bottom of the traditional inner string to the casing chute in the standard stabbing technique, enabling for zero reliance on the hydraulic integrity of the cart and ball valve during cement placement. Cementing is executed with the ball valve in the open position. In the SeaCure cementing technique of inner string cementing, the cement is placed and displaced through the inner string directly out the bottom of the casing chute and up the annulus, resulting in less contamination, quicker cement placement, and minimised cement displacement volume, as well as no shoe trap at the bottom of the casing. At the end of cement placement and the beginning of displacement, a SeaCure wiper dart is launched into the inner string, which is pumped down and lands and locks in the shoe. This then causes the aperture in the shoe to be sealed, pressure to be built up on top of the dart, and the rupture disc in the latching adapter to be pressure ruptured, opening the inner circulation path between the inner string and the casing bore, enabling for circulation outside of the conductor cart to sea via the open bore. Through the open circulation path, down the inner string, out the rupture disc, up the inside board of the conductor pipe, and to sea via the open ball valve, it is possible to place a temperature controlled warm water flush after the cement is in place and in position. This warm water flush internal to the casing enables for temperature to soak through the conductor pipe and into the slurry to elevate the slurry curing environment, causing for enhanced set times, reducing weight on cement. Each 4.5 degrees C increase in the slurry curing environment halves the set time.